Hello everyone, welcome to our presentation on leveraging beta distribution of type 1. These are the presenters. Here is the context where we will see the mathematical definition of beta type 1 distribution. Thereafter, we will see the examples based on the beta 1 distribution. Later on, we will see the real life applications, then limitations, and then finally we will conclude. So, what is beta type 1 distribution? Beta type 1 distribution is a continuous probability distribution defined on the interval of 0, 1. Basically, there are two parameters alpha and beta. Based upon that, the distribution is shaped. The beta distribution is often used to model the probability of success in the experiment where there are two possible outcomes like success or failure. The PDF of beta distribution is given by f of x comma alpha comma beta is equal to x raised to alpha minus 1, 1 minus x raised to beta minus 1, beta upon beta alpha comma beta 0 is less than equal to x is less than equal to 1. So basically beta type 1 distribution is the continuous probability distribution which is only in the interval of 0, 1. We can understand with the help of an example. Suppose you are a business owner and you are selling the product. If you want to find out whether the customers will purchase the product or not, so based upon some characteristic you judge whether the customers will buy the product or not. With the help of the beta distribution, we can print or we can justify that equations into the mathematical form and try to get more information about whether the customers will be buying the product or not with the help of the data or the outcomes. Now, in this slide, we can see based upon the values of alpha and beta, the distribution of the graph is changed. For example, if alpha is equal to beta is equal to 1, then beta distribution follows the uniform distribution. If alpha is greater than beta, alpha is greater than 1 and beta is greater than 1, then the shape will be the bell shaped. If alpha is less than 1 and beta is also less than 1, then it will be of U shaped. As we all can see here in this graph, for the value of alpha 0.5 and 0.5 where the alpha is equal to beta, then there is an uniform distribution. We can see, and for alpha is equal to 2 and beta is equal to 2, we can see the graph is slightly leptokurtic, and for remaining graphs we can see there are different patterns with respect to the alphas and betas. Now we will see an example for the beta type 1 distribution. Here in this example we can see a coin is tossed and the Bayesian update with the beta distribution is the example of this coin tossing example, where our prior belief was there will be 50% of guess whether the coin will take the head or coin will take the tail. There will be equally likely chances of being head and tail, but after conducting the experiment, like the coin is tossed 4 times, then we get the result of 3 head and 1 tail. So basically the probability of getting an head will be calculated with the help of beta type 1 distribution, because our prior belief was the 50-50% and the posterior belief that we get from the experiment is different. So the likelihood observed for the initial start of the new data is 3 heads and 1 tail, but the posterior belief will be the updated one, beta distribution 4, 2. Now more confident the coin lend heads more often. Summary: the beta distribution help us to update our brief about the coin fairness and after observing the new data. Here we will see the applications in the manufacturing industry. Suppose Rahul Bulbs Private Limited manufactures the bulb and he wants to estimate the probability of the light bulb lasting more than 1000 hours. So he have conducted the experiment where the 100 bulbs had blown up and the 30 bulbs was lasted less than 1000 hours, and there were 40 bulbs which lasted along in the range of 1000 to 200 hours, and the 13 bulbs 30 bulbs lasted more than 1200 hours. So, def defining the probability, P, probability that the light bulb lasts more than 1000 hours, starting with the prior belief that there will be an equal numbers of chances whether we draw the bulb will last long for the 1000 hours. Like if a sample from the sample of 100, if we collect a bulb, then there will be an equal number of chances like the bulb will be a blowing bulb. But after conducting the experiment, we get updating data was the 70 bulbs was lasting more than 1000 hours, and the failure was 30 bulb was not lasting for the 1000 hours. So while updating, our posterior distribution will be the beta 71,31, because the 1 is like our belief which was prior. So alpha plus success is equal to 71 and beta plus failure is equal to 31. So the PDF of beta distribution, we can see the elaborative examples of this kind of distribution. Here is the interpretations what we have get. The mean of the beta 1 distribution, mean of the beta 71,31 is 0.696, which means that there will be a 69.6% chances that the selective bulb will be last long more than 1000 hours. So what was the conclusion which we got? By using the beta type 1 distribution, the real life data, we estimated the probability of 1000 bulb which lasts long over the hours and 1000 hours and statistically reliable way. Why there is a need of beta 2 distribution? If there is a beta 1 distribution, why we should use the beta 2 distribution, and in what cases we have to use the beta type 2 distribution? Because there are some limitations with respect to beta 1 distribution. Beta 1 distributions only provide the information of the modeling values between 0 and 1, which makes unsuitable for the scenarios where the variables of interest extend beyond this range, such time event, unbounded positive values, or the real valued. For example, the time of failure, income, or weight are the examples where we can't use the beta type 1 distributions because we don't know the probability or the outcome of the following experiment. Now, second point is that it is not suitable for the probability distribution, non-probabilistic distribution, because beta type 1 distribution is bounded within the range of 0 and 1. So in non-probability distributions, we can't estimate whether we can use the beta type 1 distribution or not. For example, if a product manager sells the product and whether there will be a chances of the buying the product within the 3 hours or 5 hours of time duration, we can't predict or model this type of scenarios in the beta type 1 distribution. So there is a need of beta type 2 distribution. Flexibility, third point is the flexibility of the bimodal distribution. Since beta type 1 distributions provides this shape like U-shaped, bell-shaped, or skewed shape, but it is not naturally handled by the bimodal distribution. If there are two peaks in the given distribution, then beta type 1 distribution will not satisfy the following conditions. So there are some limitations for using the beta type 1 distribution. What we conclude from this, the beta type 1 distribution is primarily useful for modeling probabilities or proportional. With the help of alphas and betas, we can check whether the following distributions follow the U-shaped or bell-shaped curve, and the beta type 2 distributions can be used to overcome the limitations of the restricted of on the ranges. So this is our short presentation in which we have covered the PDF of beta type 1 distributions and the examples and some real life practical examples and what are the limitations for the beta type 1 distributions, and finally we have concluded what we have studied. These are some references which we followed for making this presentation. You can visit this link and check whether there is an information you can got from this. Thank you for listening our presentation.